Your car starts in 1 second. A freight locomotive takes 45 minutes. Most people think it's just a bigger engine warming up more slowly because the metal block is massive and cold. The engine's actually running in under 5 minutes. The real delay comes from several separate procedures that have to finish in order before the train can safely move, and none of them can be rushed or skipped at this scale. The most surprising one is charging the air brakes across a mile-long train. You turn the key and your engine fires before you finish buckling up. A freight locomotive crew can start their engine in under 5 minutes, yet the train sits still for 45 minutes before the wheels turn even 1 inch. Most people assume a bigger engine simply takes longer to warm up. That guess feels right, since cold metal does move slowly while warming up. But it's not the part of the process eating up most of the clock. The real answer is that several completely separate systems have to reach ready before the train can safely roll, and they have to do it in order, not all at once. That's the part most people never think about. A cold locomotive diesel is a massive block of metal, and the oil inside stays thick and sluggish until the block reaches full operating temperature. Load it hard before the oil flows properly, and the metal surfaces grind with almost no lubrication, causing serious damage fast. So the crew lets the engine warm up. But that warm-up only takes a few minutes, not 45. The real bottleneck is everything that happens after the engine's already humming. Separate systems that have to reach ready one at a time, in a specific order, because none of these checks can safely run at once. That brings us to the air brakes. Modern freight trains rely on a continuous air brake system running the entire length of the train, connecting every car to the same pneumatic circuit controlled from the locomotive. The locomotive's compressor pushes air through the brake pipe running through every car, and each one needs to reach roughly 90 pounds per square inch before the brakes can safely release. It's a bit like inflating a very long balloon. The air has to travel all the way to the last car, and the longer the train, the farther that air has to go before pressure builds evenly along the whole line. A yard switcher with a handful of cars charges its brakes fast. A mile-long freight with 200 cars is a completely different story. This is one of the least known reasons a long freight sits still for so long. The brakes are only part of the story. The locomotive also has to confirm its electrical systems are ready to safely move thousands of tons without any dangerous failure. We've talked before about how heavy machinery uses electricity instead of mechanical transmissions to handle enormous torque. And that same basic idea is at work inside every modern locomotive pulling freight today. The diesel engine spins a generator that feeds traction motors mounted on the axles. Before the train moves, the crew has to verify the generator is producing the right power and that every traction motor responds correctly to the controls, because a dead motor means a dead train. Some people look at all these separate procedures and assume the crew is simply being slow or overly cautious. That's not what's happening. The walk-around inspections and system checks aren't optional caution. They're mandated by federal safety regulations requiring daily inspections before a locomotive can legally lead a train, and the crew has no authority to bypass them. A locomotive that skips these checks risks catastrophic failure or derailment, given the sheer forces involved when a multi-thousand horsepower machine pulls thousands of tons at speed on the main line. So here's the full picture. The 45 minutes comes from several critical systems that must each complete in sequence before the train can safely move. The engine warms up, the brakes charge, and the inspection finishes. Each step depends on the previous one being fully verified, and the physics of air pressure and mechanical load simply don't allow shortcuts when you're moving thousands of tons on steel rails. This careful, methodical startup is exactly why train travel remains one of the safest forms of transportation anywhere in the world, and the 45-minute wait is simply the cost of that safety. If you want to see more hidden logic like this, hit subscribe, and let me know in the comments what machine we should break down next. Thanks for watching, and I'll see you in the next breakdown.